Hi everyone, myself N. Arun Kumar from SNS College of Technology in the Department of ECD. In this video, we are going to discuss about low power design through voltage scaling. Some of the parameters which is used to identify the voltage scaling by VT CMOS circuits, MT CMOS circuits and architectural circuits. Let us discuss how these three terminals are useful for voltage scaling. Low power design through voltage scaling. So one of the parameters which can define the voltage scaling is VDD, drain voltage. So because if your IC is a very good one, means then your VDD will be a low condition, because then only it can able to generate DC to DC voltage, or else we can make it as a DC voltage by DC to DC converters. And as per the new standard version, 3.3 voltage is the consumption of the power consumption of the concerned ICs. We need to consider this 3.3 voltage for power consumption for making an IC. And next one is the reduction of power supply voltage corresponding to the ICs are based on threshold voltage, because the threshold voltage is the one factor which can eliminate the high level voltages of the corresponding ICs. And next one is the influence of the voltage scaling on power and delay through the reduction of power supply voltage significantly reduces the dynamic power dissipation. And moreover, this can be easily done by examining the following propagation delay expressions for the CMOS inverter circuits. The following formulas has been used to calculate the propagation delay of the concerned ICs, because the delay is the factor which can affect the ICs based on the power consumptions. Low power designs can be reduced with the help of threshold voltage by applying a proper defined voltages of the concerned gate. It must be a lower VDD. The device voltage must be a lower VDD, then only it can be uh, followed as a DC voltage. The concerned voltages has been varied with the help of this normalized delay, because the delay is the factor which can affect the all the terminals which are connected in the ICs. It cannot pass the proper voltage to the final ICs, so that we can't get the original information from the packages. So let us see this graph between normalized delay between the power supply. Normally the power supply voltage is starting from 0. If your power supply voltage is more than 14, means then your delay must be 0.8, under 0.8, so that we can't get the spike in your circuits. If your voltage is more than 0.8, means then automatically there may be some spike in your circuits. We need to eliminate those information in your circuits. And next one is the circuit shows that how the NMOS and PMOS are playing while giving an input as VT CMOS. So let us consider this VTP. Initially we are giving input as 2 voltage, then automatically it just move towards the next level, next process. It is connected as a substrate control circuits. So this circuit can change your voltage as next level, because whenever we are giving the input, then automatically the concern terminal which is connected as the voltage as first one is p-type NMOS voltage and n-type voltage. Initially the power generation of the VTP voltage is 0.2 for active mode, and standby mode is minus 0.6. Why it is in minus time? Because it is in off condition, so that it can generate minus or 0. Automatically then the power can be passed to the next level, and the transistor and the corresponding NMOS is in on condition. While in on condition, then automatically the power has been generated. Initially the standard level of the voltage is 0.2 is an active, and moreover next one is standby mode is 0.8 because almost it just carry one voltage. It can have a standby voltage as forwarding the next level while it is in PMOS as off condition. So like that, the all the values has been calculated with the help of this PMOS and NMOS. So if it is in on condition, then automatically the another NMOS is in off condition, while the NMOS is non, then automatically the PMOS is in off condition. Next one is variable threshold CMOS. So far we have discussed about single PMOS and NMOS transistor operating for a very threshold voltage. Now we are discuss about variable threshold CMOS. So VT CMOS, because we are able to add more number of devices in a single circuit. It is the source which is easily identify the threshold voltages for all the circuits. The circuit voltages has been identified by using a DC to DC converter circuit, already we have discussed. And next one is threshold level, because we are connecting more number of information or input terminals to the next one, so that we need to check the threshold voltage control unit. Just adding all the additional voltages from all the unit of the corresponding ICs. Next one is multiple threshold CMOS. If you are connecting more number of ICs in this CMOS means there may be some possibility of leakaging current. In order to avoid this leakage current, we can add two different threshold voltages in the circuit, so that it just eliminate or zone the concerned leakages of the circuit. Multiple threshold, the sample format of the multiple threshold is NMOS and PMOS. PMOS and NMOS can be connected as a low threshold voltage. And next, multiple means you can connect more number of information as a parallel or serial manner. So in the standby mode, the circuit has connected as what the voltage is getting from the input is shown in standby mode. And next one is high VT transistors are turned off, because whenever we are using a multiple threshold CMOS, we need to check the threshold voltage as well as the condition of the transistor, because we are restrict the high level voltage transistors are in off conditions. Next one is low VT transistor, while cross-coupled inverter pair consisting of high VT transistor is used for preserving the data in the standby mode. While high VT transistor are turned off condition, at the time the same voltage has been occurred in the standby mode as well as in the low VT transistor and high VT transistors. Explain the basic principles behind the empty CMOS techniques in the context of voltage scaling, because multi-transistor CMOSs are the technique which can be easily identify the threshold voltage by applying a empty CMOS circuit in a parallel mode, because it just eliminate the more number of threshold voltage by using the parallel processing connections. Next one is this technique can increase the overall circuit area and also add the extra parasitic capacitance, because it just accepting less space when compared with the previous topic, so that it can be very useful for identifying the voltage scale. Thank you.